Hello, what is up everyone, Tony here, and today, as you can see, I'm going to be starting my Arduino beginner tutorial series. So, the idea for this mostly came around when I was trying to teach a couple of other peers at my school about Arduino, and I realized that they didn't really have many resources to go off of. So I'm going to try to create my own. So, in this first video, I'm going to talk a bit about the hardware of Arduino and the concept, and next one we'll probably dive into the software, and I will start with basic projects. So, as you can see in front of me, these are two different Arduino boards. They make many different versions. So this over here, this is the Arduino Uno. This is the most common one, so I think we'll focus on this for the sake of this series. And the thing with Arduino boards is, not only are there many versions, because the platform's also open source, there's also, so this is based on the 328p, I believe, but there are other ones based on, well, much different chips. Even you have stuff like the ESP Wi-Fi connected series running the Arduino software, so it's really a mixed bag in terms of what boards you can use. Also, a thing to note is not all of these boards do even have to come from Arduino. So as you can see in front of me, this one is actually just a clone. So the Mega over here is a genuine Arduino board, but you don't have to buy one. The big difference is that you're supporting the actual company. So this, for example, I bought for much cheaper online, and it works in the same manner using the same software. So, about the software, looking upon these, you might say that, oh well, this has a lot more pins, but in practice, these more or less are the same thing. So let's quickly go over what's on one of these. So you actually have two ways of powering these. What you most commonly use is the USB port. This is just a regular USB type B. You can use, well, a printer cable, scanner cable, whatever, to actually upload your software to it. Now this gets the power over USB as well as the data for your program, and you can also use serial communication. I'll go into that later. The second way, if you're going to run this on the go, is you can just use a battery. So here you have a DC input jack. This is connected to this voltage regulator, so anywhere from 7 to 12 volts usually works just fine to run all of your circuits. Now if you're packing this in a closed box, you don't have room for a DC jack, you also have this V-in pin, that's your voltage input, and you can connect this to usually a 9-volt battery, but again, any other voltage that you'd connect to this, they're connected to the same thing in the end. Now, in terms of your Arduino, over here on this side, you have your power section. So you have voltage input, ground, 5 volts, 3.3 volts, reset, and another 5 volts. If we look at the Mega, we can see it's in the same way. You have your, wrong way, there you go, you guys can now see this. You have your voltage input, you have 2 ground pins, you have 5 volts, 3.3 volts, reset, and you have IO ref, which is your reference voltage. You usually don't want to be touching that. So this is useful for connecting stuff like your voltage and ground rails on a breadboard. So breadboards will have the 2 common rails across it to run ground and voltage. So these are often useful for connecting to that. Now the next thing that we can see here going down are your analog inputs. In the case of the Mega, you have 0 to 15, so that gives you 16 analog inputs. In the case of the Uno, you have 5, but they work in the same way. So your analog inputs are connected to an analog to digital converter, because the rest of the software works fully digitally. And the way that works is there is a 10-bit analog to digital converter. So what does 10-bit mean? 10-bit is 2 to the power of 10. This gives you 1024 different levels of input voltage. So basically you have 1024 different, well, almost like dimming levels of your inputs. Same thing on the Arduino Uno. Your analog inputs 0 through 5, so you have 6 in total, are 10 bits, so 2 to the power of 10. So you have 1024 different input levels. So like half, right, for example, a half input, so like 2.5 volts would be a 512, so on and so forth. Now on this side you have your digital ports. Now the digital ports on the Arduino are pretty versatile. They can be used for digital inputs or outputs. Technically, the analog inputs can be used for digital outputs as well if you run out of pins for your project. Generally, that's not the best practice, but if you need more pins, you could definitely do that. Okay, so digital. Now so these digital pins, let me flip this so you guys can easily see the numbers. There we go. These digital pins can be used for both inputting and outputting to the Arduino, but note that they can't be used for both at the same time, obviously. So in the software you will set them either as inputs or outputs when you start your program, and we'll look at the software shortly. So you'll have to define them as either working as inputs or outputs, not both. Not a big deal though. So of interest here are, so you'll notice that on the Mega, this is not a problem. On the Mega, all of your 13 first inputs support what's called PWM, which is pulse width modulation. Essentially, it's a way of providing a dimmable output. I will go over how it works in a different video about analog inputs and outputs on the Arduino. On the Arduino Uno, not all of the pins have PWM. So you'll notice that there's a couple pins with tildes, right? So you've got pin 11, pin 10, pin 9, 6, 5, and 3. So the ones with the little tilde by their number support PWM output. So in a more practical way of saying it, they'll support dimming. You can run motors at full speed or half speed or third speed. You can change the brightness of an LED, for example. And your analog outputs on the Arduino are 8 bits, so 2 to the power of 8, which gives you 256 different levels. So for example, on an LED, you would have 256 different levels of brightness that you could set for the LED to use. Again, they use PWM. Basically, how PWM works, in a very short summary, is you basically turn the circuit on and off very fast at the switching frequency. It's multiple kilohertz for the Arduino, so it'll flip on and off multiple thousand times a second. And for example, with a motor, the motor physically can't start and stop fast enough, so you'll get the dimmed, well, slowed down motor. With the case of LEDs, the LED will actually be blinking at that super fast speed, but your eye doesn't see that fast, so you'll just see it as a dimmed light. Like if I was to move it, yeah, you get the same effect. Of importance here on Arduino Uno, pay attention to your the last couple analog inputs, because those can be used for what is called I2C. On this one, you can see there's also pinouts for it: SCL, SDA, 5 volts, ground. So that's one of the communication protocols. I'll go over a couple of them. So one of them commonly used for sensors is I2C or IIC, depends how we want to write it. Now that is a 2-wire interface. You have an SDA and an SCL. You have, well, data and clock. And you can connect multiple sensors to this bus, and you can read and write data. For example, I'll go over how to use an I2C LCD, for example, in one of the next X number of videos I make. So those can be used. Those are usually run off of the last couple analog pins. The other thing is you have serial communication. So usually serial is used natively on the USB port to send and receive data. It's on ports 0 and 1. You're usually not going to use those. If you want to connect another serial device to your Arduino, you usually use what is called soft serial, which is you will run a couple of your digital pins in a fake pseudo serial mode to emulate a serial connection. So that's the basis of the Arduino hardware. All of these are basically USB serial adapters. So like with these, you don't need FDDI breakouts like you do with the Pro Mini. You have like the reset button. Again, reset, that just, well, resets the chip, well, restarts. And you have 5 volts and 3 volts, so that's all fairly obvious. So thank you for watching this first introduction to Arduino. Hopefully you enjoyed this video. If you did, please leave a like, subscribe, and I will see you next time.